Hello, today I will show you how to design the one-way reinforced concrete slab and waiter. The first one, you need to understand the first one-way slab and two-way slab. Normally, if the span is very short, we define this is a one-way slab, and if the span between the slab is more or less the same, we use two-way slab. And this is some example. This is a one-way slab, and the width slab we also think this is a one-way slab. For flat slab, we define this is a two-way, even with a column job or waffle slab. And you need to just remember the step, and then you can understand how to find the reinforcement. The first one you can see, we define Lx and Ly. If Ly is very large, is greater than 2 times of Lx, we define this is a one-way slab. Just follow this arrow. We need to provide the reinforcement, follow the same direction. For example, you can see the bottom reinforcement, the main bar should follow this arrow, because we assume the loading is spanning, transfer from the left to the right, okay? That means for the same principle applied, the arrow should go to the top and the bottom sides, okay? And you can see the reinforcement is also will go to this direction, okay? And then show you example. This is if 4 sides is more or less the same, is equal to 1, and we call two-way slab. If L2 is very small and larger than 2, we call one-way slab. And this is a given example, the parameter given. And the first step, you need to understand the cell weight is multiple the density, and then you can find out the total dead load, and line flow is given. We just multiple the factor 1.4 and 1.6, and then you can find out the factor load. And this is the very common table to show you the typical moment coefficients. That means, for example, the interior support like this one is 0.063. That means this is an interior support. You just follow this parameter, you can calculate. And then this is also the formula, and then you can find out the D is a effective depth of the steel reinforcement. That means we divided the cover and the half size of parameter. You can find out the effective depth. Just remember and take out the value from step 2 and step 3. We can easily find out the moment. And based on this formula, just put in the figures inside. F0 is the concrete strength. D is already calculated previously, and you can just put in everything. And then you just do the same for K value. I highlight together. Just put this 0.0198 inside. You can find out the Z divided by D. But remember, one point is the value should not be greater than 0.95. That means if the value is greater, you must use the value 0.95. Like this one, we can't use 0.978. We just use 0.95. And Fy is the usage of the steel reinforcement, and then you can find out the steel ratio you need to provide. Okay. After that, you can find out the value, and then the final step, you need to provide the T10 at 250 center to center. The steel reinforcement is greater than the reinforcement you need to provide it, and this is good enough for taking the loading. And the shear reinforcement is the same. We just put everything the same, and then based on the value we provided, and then you can find out the value. And then normally I can say if the loading of the slab is very small and uniform, normally the shear reinforcement may not be required. Okay, show you some typical steel reinforcement details, and that's it. Thank you.